So going off of our previous video on figuring out how we can calculate our profit maximization problems, we are going to look at basically this is our important formula to know, to remember in order to work on these problems. So let's just get started with some practice problems. Working on these will help you understand the concepts much better. So first example is, suppose that our production function is this. Where P is equal to 80, W1, so wage of the first one is 80, and the wage of the second product is 16, and X2, the second product, is a constant, right? So you can think of it as a capital. And how do I know that? Because of that little dash, right? X2 is constant, it's 8, so the price is 80, 20, 16, 8. Okay. Now you just have to find that X1, right? You just have to find, write the firm's profit maximization problem, and when you're writing it that way, you can see what our optimal good one value is, our optimal value for good one, right? And okay, so going back, whenever they say, okay, write the firm's profit maximization problem, you have this little formula here, okay, this little thing here. Just going off of this, right? Just going off of this, we have the same thing here, right? We just plug that in, right, into this formula. We have 80 given the that's the price, and then we have the production function, right? That's already given, and then the wage times X1, and then the wage times X2. These are all given, so that's great. And this one is what we're looking for. That's our answer. That would be our answer. And now, in order to find the profit maximization, right, we take that derivative. But thankfully, in our previous video, if you look at my previous video, we've already done that. And this is going to be our equation to solve for, right? We have, so just plug that in, right? We have this, right? You might be asking, where did that x1 to the power of -1/2 come from? Remember, when we're doing the derivative, we have to remember to derive our function too, right? That's our production function. We have to derive that. So that's our MP, that's our marginal product of good one. Again, you don't need to take the derivative of this one, of good 2, because that's a constant, so don't worry about that, right? Here, this is just basic calc, right? When you're trying to take the derivative of 2 times x to the 1/2, that's the same thing as square root of x, just the basic calc, you will end up with x to the power of -1/2, right? Now, all we have our numbers, we have everything. We can just do 80 times our MP, right? Price times MP. Is equal to our wage, which is 20 for good one. Always remember, which good you're talking about, because it can create some problems when you're trying to when you're in an exam. Okay, simple math now. Divide it by 80. Divide 80 on both sides, and you get x to the power of -1/2 is equal to 1/4, right? That is the same thing as saying 1 over square root of x. Ooh, okay, 1 over square root of x. Right? Whatever, you get this first. 1 over square root of x is equal to 1 over 4, right? And then you just do cross multiplication. You'll get like 4 is equal to square root of x1. So, square root of 16 is 4. So that's why our optimal condition is going to be 16. So at 16, when you have a quantity of 16 for good 1, you can find that profit maximization. That's where your profit is maximized. You can feel free to pause this video and work on this specific problem, which is similar to the one that we just solved, and this one too. So feel free to pause and get some extra practice, but I want to focus on a different one because a lot of students might make a mistake on their exams because there's a little small confusion that might pop up. So for this example, there is a production function with that is 4 times square root of x, and the price is 80 and wage is 20 again. So that's great. And that's all that's given to us because to be honest, that's all that we really need for these problems, if you look at the first one, right? Now we want to know what's x asterisk. That means, what is the optimal x that we need for our profit max, and because this is a profit maximization problem, assuming that, and then just find the profit, right? So for number one, very simple, right? The numbers are pretty similar to the one that we did before, just to kind of make sure that we understand the concept rather than chugging in numbers. So how I like to do this problem is, before I even start, I like to find the derivative of our production function, because I know that I'll be using it in order to find the profit max equation. So I am going to take the derivative, like right here, right? Basic calc right here. So it's just 2 times square root of 2 over the square root of x, which is the same thing as 2 times x to the power of negative 1/2, right? Now it's very simple, because for our profit max, I know my formula is PMP1 is equal to W, right? Just like the one before, PMP1 is equal to W. It's everywhere. It's everywhere. And that 1 could be replaced with L, could be replaced with K. It's arbitrary, right? So we have PMP1 is equal to W, and I can just plug my numbers in, right? I know that the price is 80, and I know that our marginal product is 2 over square root of x, because that's given here. And I know that my wage of good one is 20, and I just do the math, right? It's just 2 over square root of x, yes, is equal to 1 over 4, and then you do cross multiplication, right? 2 times 4. 2 times 4 is 8, is equal to square root of x. And what will give you 8? What square will give you 8? And then you get, square root of 64 will give you 8. So I know my optimal is 64. So moving on to our next problem, the confusion comes here when we're trying to find out our profit. A lot of times what we do is, we know that our profit function is just this, right? It's price times quantity minus our cost, right? Again, it's revenue minus cost. And what students like to do accidentally is they assume that our quantity is the 64. They assume that the Q is the X, and then they just have a totally different calculation, right? What we should be doing is actually plugging it into the function f of x, and not just the quantity, okay? The function is, embedded. It's function with respect to our x. So the quantity will be dependent on our x value that we find in the first problem, the first part, that's 64. So then we plug it back in, right? Because the quantity is our production function, so the quantity is our f of x, right? Now we have all the values that we really need, so that's really helpful. This little note is really helpful. So the profit is P times f of x minus, wage 1 times the cost of that, or quantity, good 1. And then profit is 80, which is a price, times 4 times the square root of 64, right? Because looking back at our production function, f of x is 4 times the square root of x, and we just plug that x into that, okay? And then minus wage is 20, we know that, and then x1 is 64, right? Because we know that from our previous problem. Then we just do the math, 80 times 32 minus 20 times 64, and you get a profit of 1,280 units, right? So that's the most important thing. If we could not have solved this problem without solving our optimal bundle for our profit max in number 1. We could not have solved 2 without number 1. So that's important to notice. So just with a lot of practice, I think that these types of problems will get much better. It's just important to know these formulas, important to know why we're using what we're using in order to understand this concept better. So thank you.